Hey guys, in this video we're going to use the quadratic formula to solve quadratic equations. And it's one of my favorite formulas because it will work for almost any equation that you can write into the form ax squared plus bx plus c equals 0. Because this is how you can extract the values of a, b, and c, and it makes for a nice, easy solve in order to find those two x values that you're looking for. So let's look at the formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And this is going to give us our two x values. I have highlighted the discriminant b squared minus 4ac because to me it's one of the most important pieces of the puzzle. I want to make sure I get that right as I move forward through these problems. So first example, a is 2, b is 7, and c is 8. And I typically work this in a two-step process. I find it's less of a burden to go ahead and calculate b squared minus 4ac first, make sure that's right, and then continue with the rest of the formula. So I'm going to plug in 7 squared minus 4 times 2 times 8, and I'm going to double check that and triple check it. It's negative 15. This is telling me I'm going to have two imaginary solutions, which is perfectly fine, but at least I know that this number is correct and I can move forward. The second step, I'm going to plug in the rest of the values or use the rest of the formula and go ahead and break it apart and clean it up. So negative 7 plus or minus, when I put in that square root of negative 15, that's going to simplify to a square root of 15i, imaginary, and 2 times 2 in the denominator is 4. So my two possible solutions are negative 7 minus square root of 15i over 4 and negative 7 plus square root of 15i over 4. Okay, let's take a look at the second example. So we have our a, b, and c. A is negative 2, b is 6, and c is 1. And I'm going to focus on the discriminant first and plug in those values for the discriminant. 6 squared minus 4 times negative 2 times positive 1 is 44. The second thing I'm going to do is just plug in the rest of the formula, plug in numbers into the rest of the formula. Negative 6 plus or minus square root of 44 over 2 times negative 2. The square root of 44 is irrational, and I need to break that up, and I also need to clean up the formula a little bit. So I'm going to rewrite it as negative 6 plus or minus square root of 4 times 11 over negative 4. And I'm going to evaluate the square root of 4 as 2 and clean it up a little further. Negative 6 plus or minus 2 times the square root of 11 over negative 4. At this point, don't be tempted to just cancel anything willy-nilly. Make sure that if you are going to reduce or cancel, that all three positions in this expression have common factors. And they do. You can actually divide out a negative 2. The negative 2 will divide out and give us a positive 3. It will give us a 1, and it will give us a positive 2. What's nice about dividing out a negative is it takes care of those two negatives that we used to have there, and it doesn't affect the plus or minus sign. So to clean this up, I'm going to write the two possible solutions of 3 minus square root of 11 over 2 and 3 plus square root of 11 over 2. Now earlier in the video I talked about how these are two x values, they're two solutions. And if you remember, when we were factoring, we were actually finding two x values where the function touched the x-axis. So I'm going to just kind of give you a little bit of a preview and show you that the graph of this equation, what we found are the two positions where the graph crosses the x-axis at that 3 minus square root of 11 over 2, 0, and 3 plus square root of 11 over 2, 0. Just stick a pin in that and keep that in mind as you're working on these because you'll be graphing them soon. What happens when the numbers are imaginary? Well, again, a little bit of a sneak peek. The actual graph itself doesn't touch the x-axis, which is why we have two imaginary solutions. And in my mind, I think, well, what would happen if we did a little ghost version of this graph and we flipped it over? Well, if we flip it over, it would actually touch at those positions on the x-axis if it were flipped over. So in my mind, this is how I think of it of, okay, these are the numeric positions of where it would be if it had flipped over and touched the x-axis. So keep this in mind as you move forward too. That's why the solutions are imaginary, because the actual graph does not touch the x-axis. Let's look at one last example. And in this one, you'll notice that this is not in the format. It's not ax squared plus bx plus c equals 0. So we need to adjust it so that it is in that format. What we will do is go across the equal sign, and we're going to add the 10y, and we're going to add the 1. Bring that all over to the left and 0 out the right-hand side. So that will give us a 25y squared plus 10y plus 1 equals 0. Now notice, if you had just started the problem with a, b, and c, your signs would have been different. Our signs now are a is positive 25, b is positive 10, and c is 1. And that's important in order to get the graph right, in order to get the solutions right. Going to go ahead and plug that into our discriminant and find that 10 squared minus 4 times 25 times 1 is 0. This is one of those special cases. So let's plug in the rest of the formula, put the numbers in. It's going to be a negative 10 plus or minus square root of 0, which is 0, over 2 times 25. This cleans up to a negative 10 over 50 because it doesn't matter if you add or subtract 0 from anything. It doesn't change it. So we actually only have one solution here that we can reduce. It is called one repeated solution. Divide by 10, and that's 1 over 5, or negative 1 over 5. And on a graph, what that looks like is it's the vertex of the quadratic equation. It only touches the x-axis one time. And that's what happens when you plug those numbers in. It'll show you that. So keep that in mind, and I'm going to wish you luck as you continue to use this formula and deepen your understanding of these concepts.